Okay, welcome to lesson 80 of algebraic concept functions. So, this is the second direct lesson dealing with functions. Patterns and sequences kind of relate to functions because functions are a pattern, and you will see that in upcoming videos. So, uh, I would tell you the series that this is in 80 is about 30 or 40 more lessons dealing with functions. And functions are interchangeable with graphs and tables and situations and stories. So it's all kinds of ways to look at functions and series and stories. The functions or equations is the popular name in math classes we will deal with, uh, and what kinds of graphs they produce is a major part of algebra, and it will end once we get to polynomials. So once we begin polynomials, we will be over our function sections. So I'm not going to tell you how many lessons. I mean, we go from 80 to about 118, 119, maybe 120. So that gives you about 40 lessons, aside from the previous 6 or 7 that we looked at. So we have 40 to 45 lessons dealing strictly with functions. So that's functions are a big part of algebra. All right, here's our objective, our vocabulary, some rules and notes for you. Uh, Anytime I put these pictures in, I intend for you to stop and read through that. I really intend for you to stop and read through the vocabulary, but these pictures that I put in will come up at another point in time. So we kind of skimmed through this in the last lesson, but let's look at this. An airplane climbs 20 feet each second after takeoff. Write an equation or function rule that describes the relationship between time and altitude. So, all right, how you read a story is each. Each, whenever you see the word each, every, per, and sometimes for, these mean divide. And so a relationship, a proportional relationship, is maintained between feet and seconds, which means there is your relationship, feet over seconds. So this means that feet will be the y and x will be seconds. So your domain will be time, your independent variable, your input, and your output will be feet, your dependent or your range, feet. That's enough mean to be a T. So we're dealing with time and feet, and we're looking for the change. And so the relationship is the change in y divided by the change in x. So we see that the x is changing by 1 each time. So the change in x is 1. The change in y is 20 each time. And so that's 20 over 1. So that gives us 20 feet per second, every second, each second. So now, our function rule. We write a function f of x, a function of x, because x is our independent, equals the rate of change times our variable. So this x here goes here. And so f of 1 second will be 20 times 1. And then that's how we calculate. F of 2 will be 20 times 2. And then f of 3 will be 20 times 3. And if we do the multiplication, we see we get 20 at 1 second, 40 feet at 2 seconds, and 60 feet after 3 seconds. And that's how you write a function rule from a table of values. Okay, so let's look at our second example here. So what are we given? We see that hours is on the left, so that means it's x. Dollars is on the right, so that means it's y. But when we're talking about terms of functions, we have f, x, and then y changed to f of x. So hours is our x, dollars is our f of x, and the rate of change in a story is f of x divided by x. But then we give $5 to charity. So what happens? We 45 minus 5, and then his second hour is 2 times 45, which is 90, but then he gives $5 to charity. Then for 3 hours it's $135 minus $5 for charity. So write an equation or function rule. So if we're talking about a function rule, we start with f of x equals 45 times the number of hours minus the $5 he gives away. Now, if we're talking about an equation, and this is how you usually see it, is 45x minus 5. And what's the difference? When you're talking about a function rule, f of x. When you're talking about an equation, y. And this form is used for graphing. And this form is used for graphing too, and you will see it on some online computers. But this is the bottom one is usually most commonly and most popularly used, and that's why we do that. So that is example 2. Okay, and let's look at example 3. For the function y equals 2x minus 3, find the y values for the domain 0, 1, and 2. Then identify the range of the function. So here we go, going back and forth between y and f of x. It's the same thing. So what happens? If x, 2x minus 3 is our function, we want the f of x or the y. They are the same thing, so please don't get confused. So we're looking at 0, 1, and 2. So we substitute 2, put your substitution in parentheses so that you know what you're substituting and you don't get your signs mixed up. 2 times 1 is 2, minus 3 is minus 1. 2 times 2 is 4, minus 3 is positive 1. So the rate of change always multiplies to x, and then minus 3 is where we start at. So if our domain is 0, 1, and 2, the set of our domain, and we put in these squiggly parentheses, 0, 1, and 2, then our range is from negative 3 to positive 1. So our range goes from negative 3 to positive 1 for the domain 0 through 2. So that's just a different way of using domain and range, and technically that's how you use it. So those were our 3 examples. I will meet you at the end of the video for a review. So try to practice problems and meet me at the end of the video. Okay, so write a function. Bailey goes to an amusement park. The admission fee is $6. The ride tickets for ride costs $5 each. One ticket is needed for each ride. So the admission fee is an additional cost, but we want to know how much money is spent. So our f of x, rides cost $5 each. So that means $5 per ride. This is our rate of change, $5 for one ride. So the rate of change always multiplies to your x. Our x is ticket. Because that changes. And then add our admission fee. So tickets for rides cost $5. One ticket is needed for each ride. Write a function rule. So this is how we identify what we're given. And we'll come up with fancier names as we go through the rest of the lessons. So there's 40 more lessons dealing with functions in all kinds of ways. Okay, so let's look at our last problem. Evaluate the function for the domain. So what you're going to do is make 3 columns. Your input, -2, -1, 0, 1, and 2. You put your expression in there. This is an expression, not an equation, because it doesn't have an equal sign. And your output, you can write f of x or y. So -2.5, when we substitute, use parentheses. This way you keep your sign straight. Okay, so let's deal with this. The reason why we put our substitution in parentheses is so that we keep our signs straight. So -2 times -2.5 is +5. Add that to 6 and you get 11 as an output. Let's do these in blue. I should have did that top line in red. So this is making an input-output chart. -2.5 times -1 is +2.5 plus 6 is 8.5. -2.5 times 0 is 0, so we just get 6. -2.5 plus 6 is 3.5. Because 6 minus 2 is 4, then minus another 0.5. -2.5 times 2 is -5 plus 6 is +1. And there we go. So the range of our function is 1, 3.5, 6, 8, and 11. It goes from 1 to 11 for this domain only. Outside of this domain, the numbers change. So that is this lesson on functions. We're going to roll into the next one, which is relations and functions part 2. And all these videos will be similar. So please watch them in a series starting with 2079. If you need to go back and watch sequence and patterns, they kind of relate to this, but they're a little bit different conceptually. Everything is related, but it does not talk about functions with this specificity. So thank you for watching. I will see you on the next video. And if you like what you saw, subscribe and hit that notification bell.